All right, so the main idea in notes for 2.2 and 2.3 is the different types of graphs that are used in statistics. And so you have to be able to know what they are and how to make them, like what the differences are, okay? So we have histograms. Hopefully that one's one that you recognize. That one's one of the more common ones. It uses contiguous, which means they're touching. There's no gaps in them. Vertical bars of various heights. And they represent the frequencies of the classes, so it tells you how many times those occur, okay? This is the one that's probably the one you are most familiar with. You should have seen these types of bar graphs in like middle school science classes and stuff like that, okay? A frequency polygon is a graph that displays the data by using lines that connect points. And actually, sorry, it doesn't just connect points, it connects the midpoints. Plotted for the frequencies at the midpoints of the classes. The frequencies are represented by the heights of the points. So for a frequency polygon, you have your class width, you find the midpoint of it, which is kind of why we were doing that in some of your problems yesterday. And then you put a point at each of the midpoints and then connect them. So it's a line graph, but it's connecting the midpoints of the class widths. Because it's basically what it's doing is it's giving you a general overview instead of specifics. And then the ogive is a graph that represents the cumulative frequencies. Remember, cumulative frequency is the frequency class you're looking at and everything before it. So when you finally get to the end, your percentage is 100 or your frequency is 1. Now, this one, instead of doing percentages, it's adding up your individual frequencies. So it can do it either way. It can either use a percentage or it can use just the total number. Does that make sense? Yes? Okay, you have different distribution shapes. So these are similar. These are going to be histograms, okay? You have different distribution shapes, and there's several of them that you have to be able to recognize. The others come up sometimes, but I'm going to kind of highlight the ones that are the really important ones. So you have your bell-shaped, which means it looks like this. So you guys have heard of the bell curve, right? Yes, generally speaking, anyone don't even have a clue what I'm talking about. Okay, so in college or in statistics, and we're going to be talking about this one the most in here, it basically means that you have the middle of your graph is the average, and then it sort of tapers off in a uniform way. And we'll talk more about it, but the important thing is that you recognize it's a bell. So it looks like a bell if I draw this. Okay, it looks like that. That's called a bell curve. The reason why I would have expected most of y'all to have heard about it is you hear about college professors using the bell curve all the time. And that's why a lot of kids know what it means. The other one, uniform, it means that it's generally speaking it's just like a flat line. Obviously, there's a little bit of variation. It's not completely flat. But overall, looking at it, it doesn't have many peaks or anything. J-shaped and reverse J-shaped, I don't think are two that are used very frequently. So you've seen them? Great. Okay. The difference between the J-shape and the skewed. Looking at it, J-shape goes to the highest or starts at the highest, whereas skewed does not necessarily have to. But it is important that you understand skewness if you're looking at one of these graphs, because this is the part that people get backwards. Skewness, you have to look at which way the tail goes. Do you understand what I mean by I said the tail? Okay, the part where it sort of tapers off. So right skewed has a tail to the right, whereas left skewed has a tail to the left. So knowing skewness by looking at a graph is very important. If it's uniform, that top left one, that does not have any skewness. That is actually perfectly bell-shaped if it's uniform. Bimodal, any idea what you think that means? Any clue at all? The name gives a hint if you know what the name means. Bi means two modes. So that means if you're looking, remember, mode is how often, the one that occurs the most often, and you can have more than one mode. So looking at a graph like that shows you that the data has two separate modes, two times where there's two different data points that occur the most, and they occur the same number. So bimodal just means you have two modes. U-shaped, that one's kind of obvious. Again, those two probably aren't super high on importance list out of all of these, but you might see it. So U-shaped, obviously it looks like a U in the middle. Okay, so it's opposite of your bell shape. We're putting the data in L1. Go to your window. So my X-min, what I do is I look and see 100 is my smallest, so I'm going to go a little bit below that. So I'm going to say my X-min is 95. My X-max, my highest value is 137. Oh, no, 134. So I'm going to go 140. My X scale, I'm going to use 5. And then Y-min, when I look at this, if you go and actually figure out your classes and how many there are, nothing occurs more than once. So doing a Y-min of, I'm going to do -5 so that you can really see without there being any hindrance on your graph. And then the most that occurs in one of my classes is going to be, one of them occurs 6 times. So I'm going to put a Y max of 6 and a Y scale of 1. So again, if you missed that, it's second Y equals and select plot 1. Turn on your plot down at your type. So the first one is a dot graph. The second one is a line graph. The third one is a histogram. So that's the one you want to choose. So make sure that that one's highlighted. Your X list is going to be L1, should be automatically preset to that. And then frequency is 1, doesn't matter about the color. And then you should hit graph. And you're going to be able to see what that histogram looks like. All right, so any questions on that? No? Okay. Okay, on occasion, you will have a reason to create a histogram from grouped data. So when it's asking you to do that, what you're going to do is you are going to find the midpoints of your class boundaries. Okay, so my midpoints of these are going to be 102, 107, 112, 117, 122, 127, and 132. So here, whenever you do this, it's going to be, these go into L1, these go into L2. So that's like your X and your Y. So when you go into your data, so remember, when you go back to your list, stat edit, highlight L1, hit clear, not delete, clear, and then enter, and it clears out all of your data. And then you'll go type in your midpoints into L1, your frequency into L2. And then again, whenever you go, I think that, I'm trying to think, I don't think you need to Yeah, you need to change your window because now I have a height of 18 for one of my frequencies. So your X-min and max, I believe, can stay the same, but your Y-min and max is going to now be, I'm going to do like -2 up to 25 for my Y-min and Y-max. Y scale, you can leave it at 1 or you can change it. It's not going to do anything other than how close your tick marks are going to be. Okay. Then whenever you go to stat plot, when you go to frequency, you're going to tell it to select L2. Remember, L2 is second and then number 2. And then when you hit graph, hopefully you're going to have the histogram that's going to have all of that there. All right, creating a frequency polygon, you literally do everything for the grouped histogram. In number 3, so whenever you go to select your stat plot, you're going to choose the line graph. So instead of the histogram, you choose a line graph, so the second one. You should have L1 and L2 for your X list and Y list. It doesn't matter what your mark is. It's whatever you want. Doesn't matter. I would suggest eat one of the first 3 so that you can see it. And then when you graph that, hopefully you'll be able to see your polygon frequency polygon there. And then in Ogive, so when you go into your data, you enter the first lower class boundary and put it as 0, I believe. And then you do your next lower class boundary and then you have to add them up. So remember, for the frequency polygon, for the Ogive, what you're going to do is you're going to say 100 is your first one and it's 0 because there's nothing, remember, it's everything below that number. Then we're going to go to 105. So everything below 105 is going to be 2. So you're going to have one extra piece of data that doesn't really exist. It's just in there for the purposes of setting up your graph right in the calculator. Okay? And then so you have one extra one, that's 0, and then everything else you're going to use these. And then remember you're adding, so it'd be 2, then 10, then 28, etc. So for Ogive, you're adding the previous ones as well. And then you just follow all those directions. And that is how you create an Ogive in the calculator.